Let's dive right into this. My name is Ken Holder. I'll be going over the Big Bang and the dark matter, the theories of that, and the thought processes, origin of the universe. Okay, I'm sure you've heard the news. The universe is a lot stronger than we imagine. Okay, let's dive into this a little. So you see, the universe started with this Big Bang. Okay, it's like just black, a really big one. Boom, just like that, just the beginning. And after the Big Bang, the universe exploded into existence, stretching and expanding. But here's the kicker. Most of this stuff, but there is not stars, planets, or even pesky asteroids. It's dark matter. Think about dark matter as this universal invisible glue. We can't see it, but we know it's there because it holds the galaxies together. Without it, everything would just drift apart, right? Scientists believe matter, black, at least dark matter, makes up 27% of the universe. That's a lot of invisible glue. Dark is causing the universe to expand in forms of all this energy? It must be incredible. Simply, okay, if I was to summarize this, simply put, space in time is the dark matter that is impossible for us to see. And that's also part of the Big Bang Theory. 6 billion years ago, the universe has grown big enough for dark energy to overcome the attractive force of gravity and start speeding up the expansion. The nearest galaxy goes beyond our visual horizon. Despite its complexity, the universe is made of three ingredients. One is matter. Matter is all around us. It's dust, rocks, it's mass. Second is energy. Energy is what you feel from sunlight, and in space, stars, they really rely on that to give them energy. Space is number three. Space is not emptiness, it's properties. It can bend, curve, ripple, and expand. When Albert Einstein built his famous equation E equals mc squared, he showed that matter and energy was basically the same thing. Check this out. The map of the radiation of the Big Bang was taken by ESN's Planck spacecraft captured by the older light. This information helps astronomers determine the age of the universe. I mean, the idea here is that they're trying to find the baby picture of the universe. Researchers and scientists are looking for the baby picture, the origin, that first light of the universe, as far as make a relationship between that and like a person. Simply put, it says the universe as we know it started with an infinity, hot and dense single point that inflated and stretched. First at unimaginable speeds and then at a more measurable rate over 13.7 billion years ago to still expanding cosmos that we know today. Around 13.7 billion years ago, everything in the universe was singular, condensed, and suddenly there was an explosion that began ballooning our universe outwards faster than the speed of light. This was a period of cosmic inflation that lasted fractions of a second quickly. 2. Now, physicist Alan Guth in 1980s theory changed the game. We looked at the Big Bang Theory in a different light. At this time, everything was insanely hot. And we're talking about insanely hot. 10 billion degrees. Whew, that's really hot. The cosmos now contains a vast array of particles such as neutrons, electrons, and protons. The raw materials that become the building blocks for everything that exists today. About 380,000 years after the Big Bang light shined through, some call this new light the afterglow of the Big Bang. Its proper name is Cosmic Microwave Background, CMB. CMB. Has the Big Bang Theory been proven? Is a question to ask yourself. And I'm going to answer it for you. All the information gathered is consistent with predictions of the Big Bang Theory. So yes, it has been proven. Now, there are some observations. There are many. But these are the main three, and I'll give them to you here. The Hubble law shows that distant objects are receded from us at a rate proportional to their distance, and this implies that history is where everything was closer before and now it's not. The properties of the CMB, remember that it's cosmic microwave background. This shows that the universe went through transitions from ionized gas and a neutral gas. Okay, this implies a hot, dense early universe that cooled as it expanded. The relative abundance of light elements formed during the Big Bang, and their abundance shows that the universe was really hot. The term Big Bang was used in the late 1940s by astronaut Fred Hoyle, and it caught on in the 1970s. Oh yeah, this is cool, we can use it now. We can also call part of the Big Bang Theory the CMD, which is also called cold dark matter. Hey, don't get it confused. The CMB is the cosmic microwave background, and the CDM is the cold dark matter. This theory predicts that the structure we observe today were formed by small galaxies collided and merged, triggering the star formation. Dark matter is completely invisible. It emits no light or energy, and thus we cannot detect it by conventional sensors or detectors. It pulls matters together. Dark matter is a topic linked to the Big Bang Theory in several ways, including the possibility that it may have existed before the Big Bang, or that it may have created during a second cosmic explosion. Now, the dark energy is a repulsive force that pushes matter apart, and the dark energy and dark matter takes up a lot of space in the universe. So the next time you're outside and you look up in the sky, remember there's way more than meets the eye. You look up and you see a star, that's another galaxy. It's a Milky Way. And again, thank you for taking the time to look at my video. This is Ken Holder. This has been a pleasure. Introduction to Science 2024. Thank you.